So here's what we're going to do. You got your agendas. We're going to start off with Jeff Smith, who's the CEO of Arago, and we're going to talk about artificial intelligence and what this company is doing around its hero product and its platform, and gives you a little idea about where artificial intelligence is going, and then we're going to go into a full panel that Robin will be moderating from that particular point. So without further ado, it's all your stage, Jeff.
Thank you, sir.
Thank you.
Good afternoon. So first, thanks for the chance to chat with you all today. Jeff Smith from Arago. Arago is a private equity-backed technology firm. We have a general purpose artificial intelligence solution set that has been branded HIRO, H-I-R-O. And what our platform does is resolve issues. Now, that sounds pretty simple until you consider the kinds of issues that we resolve, which can be complex, multi-data center, global network downtime issues. They can be cybersecurity attacks ranging in the thousands of denial of service attacks per minute. So they can be big, hairy issues that our platform handles, or real simple ones like, we're running out of memory on this batch job. Please provision it in the next 10 minutes so the job doesn't run out of memory. Those are the sorts of things that a general purpose AI platform can do. What I wanted to talk today about, I guess, is our view of more of the landscape we're seeing artificial intelligence and all the various permutations of labels that AI represents right now, whether it's machine learning or a variety of other things that you might hear or see in various media. And I think one thing that struck me in learning more about the marketplace as I joined the company is the way that AI interplays with the two other big topics on people's minds, one being digital and digital transformation, which is everybody's favorite topic right now, and then IoT, which we're here to talk about today, which is really the physical manifestation of digital transformation. So three things, lots of interplay between them. But I think probably the biggest question that we get asked as a business and a vendor in the marketplace is, how much of this stuff is real? And how much of this stuff is still basically a giant science project? And I think the question that is on buyers' minds, and not sure how many of you represent companies that are looking at this as a consumer of technology to solve business problems versus those that might be service or software or product vendors of various kinds trying to solve those problems for customers. But whichever side of the table you're on in this conversation, thinking about how real something is, and reality here is not about the technology being real, because there's some very exciting stuff that people are doing. Walk on this floor and other venues, you can see it. The real question is how much of it is real in addressing a business problem in a way that today we can't. And so we like to say that there's two ways to think about this. One is AI as a science project versus a game changer. And the question, I think, for the customer is, which do I want? Am I interested in a science project to learn, but I don't really have an appetite or an understanding or a risk profile that lets me take on doing something with this if it works? Or am I looking for a game changer because I have a significant economic or operational business opportunity, and I need to fix that opportunity and address it at speed, and I need something that'll do that differently than what my competition can do? And can AI help me with that? Success. So the first thing I guess I'd say is, as we think about the landscape for AI, the first thing we tell people is you have to think pretty holistically about this. Ultimately, the idea of an autonomously run business, and heaven knows you hear enough stuff. We were looking at an autonomous car that was a Corvette, which as one of my colleagues remarked, almost seemed like sacrilege to put a connected car, self-piloting driver in a car like that. And I think if it was a Lamborghini or a Ferrari, it'd be just as bad, right? Because you don't buy those cars to have someone else drive it. You know, you buy it so that you can drive it. Well, the notion of autonomously run stuff is something I think that's becoming more accepted as an idea that people want to explore and evaluate what kind of benefits it can bring. The benefits could be safety. The benefits can be performance. The can be error avoidance, so cost, quality, and maybe cycle time or speed, all being dimensions of how you measure what the difference can be in autonomously run stuff. And our view is we're looking ahead to a view where businesses or significant business operations can be enabled with artificial intelligence engines to run an operation autonomously. I'll give you an example. Today there is a consortium that is building a refinery of the future for the oil and gas industry. Their intention is to make that refinery autonomous. So if you consider that out of the significant disasters related to refineries around the world over the last 20 years, 100% of them were caused by human operator error. You get rid of the human operator, you've done something to change the risk profile of operating a refinery. And that is the idea behind a couple of the big sevens view of what can be done by attacking the issue of autonomous run refineries as part of a broader refinery of the future idea. I can tell you that same consortium is looking next at offshore oil rigs. And they're talking about drone oil rigs. Same notion. We're going to dramatically change the risk profile and operating characteristics by introducing an AI engine to drive the electronics, the IoT that is pervasive throughout the design of these things in a way that allows you to not just do the information technology part, but the operational technology part too. And that's part of what we also think you have to consider in judging whether you're talking about a science project or whether you're really looking at a game changer. As we talk to our customers, and we also talk to our service provider partners in the world who work with us, a few questions keep popping up these days as ones that are in the front of mind for many people. And it's large part because of the success all of us have had in introducing technology and making it a core part of the way things work. One is that once you become dependent on a technology, when it goes away, when there's an outage, it's a bad thing, right? Consider, I was at a conference in May right after Memorial Day, and at that conference, it was an investor conference, and one of the guys in the audience said, well, tell me about what the value is of outage prevention. I said, well, if you're the CEO of British Airways right this minute, if you remember Memorial Day weekend, what's the value of an outage that you were able to prevent last weekend? Because right now people are talking about taking your job. Your stock prices dropped 20% in 3 days. There's real value when technology goes away to preventing that from going away because of the dependence all of our business operations and interconnectivity in our ecosystems now has around the availability as well as the performance of technology we depend on. Second big issue is the cost of complexity. You know, the comment at the onset about integration, how we're going to integrate all this stuff. As we add billions and billions of data points that are sensors of various kinds, and I have the dubious pleasure of being part of the original Auto ID Center at MIT back in the year 2000, 2001, and 2, and I had a chance to work with the seminal group that built the original business case for RFID in the consumer products and retail industry. And if you go out and look at their website, believe it or not, there's still a white paper with my name on it. I didn't believe it was still out there for 15 years, but it is. The thing that we were talking about even then was what happens when every tube of Crest toothpaste has a tag on it. And we're tracking, and here's the thing we talked about is, let's say you've got a pallet of these things. That's 84 cases to a pallet, and you're sitting in the back of a Walmart supercenter. And that was delivered from Procter & Gamble from their warehouse some time ago. Here's what happens. Every read of that case and of the items in that case constitutes a data point, right? And if I'm reading 40 times a minute against all the tubes in 84 cases on one pallet, all the data points I'm generating are saying, since the last read, which was about, a second and a half ago, nothing changed. So I have state change issues I have to have some intelligence to process because the raw data that is just the reads themselves is massive. And that's for one pallet of Crest toothpaste. Now you start looking at things that might be fresh product with sell-by date, expiration issues. And I want to have the ability to capture that additional attribution and track whether something needs to be rotated in the shelf stock. And as we chase through the supply chain and the merchandise management issues and food safety and the cold chain and the other things that are associated with that particular vertical industry, and we're not looking at pharma here, we're not looking at biotech, we're not looking at aerospace, all the others that have their own set of issues like this. This notion of billions of data points, most of which is not interesting. It's not information, it's just data. Really challenges what the technology community can do to isolate and abstract the stuff that does matter from the stuff that's there. And that was an issue we were talking about 17 years ago. So not a new topic, but as it's turned out, it's been a big topic ever since. And of course, if you're a network guy, particularly if you're selling bandwidth, it's like, whoa, this is great, man. Talk about via video, and now the next big thing is IoT, because all these zillions of transactions are going to be flying around my network, and I get paid for that. That's great. If you're the customer, though, most of the value is not in those transactions. It's in the abstracted information that comes from it. And something has to be smart enough to be able to abstract it and process those volumes in a way that it's useful information rather than just historic records that you catch up to too late to do anything about it. So cost of complexity tied to these data proliferation issues, and IoT is a huge data proliferation issue, is a big issue too. I mean, a third thing that I think if you've ever been a CIO, and I was a chief information officer of a $5 billion manufacturer as part of my career, I can tell you this was a problem for me, was when 70 to 80% of my budget was tied up in keeping the lights on, it didn't leave much room to do any innovation. Even though my board, who all read the Wall Street Journal or the Financial Times, is coming to me regularly and saying, what are we doing about innovation? You're the CIO, you're supposed to be innovating stuff. Well, that's easy to say. You want to give me some CapEx? Don't have any CapEx. You got to figure it out from your own operation. So the challenge of abstracting cost from my run side to be able to move it into my change the business side is another pressure point that's very significant for anybody here who's a vendor trying to sell to a buyer. And that every year, it's a problem. I can tell you, for all the hue and cry and the number of McKinsey studies and systems integrators doing work in this industry, and I was with Accenture, Anderson Consulting, and Arthur Andersen going back to 1979, so 29 years with that company. I've seen the elephant, all right? I can tell you that customers today, CIOs today, are still confronted with the 70-30 problem. It has not gotten better. It is a tar baby. And the problem is you put your hand on it here to try to unstick yourself here, and now you're stuck here. It's very hard to extricate yourself from legacy. And that issue traps your cost and traps your spend, so you can't spend it very easily on change. So that's another issue people are wrestling with. Speed to deploy is another problem, because when we bring new solutions to market, it takes a long time to actually get the change to show up at scale. Pilots are easy. Agile, Scrum, I'm sure everybody's run into that if you're not doing it yourself. Great concept. Iterative development's been around since the 1970s, in my personal experience, so it's well proven to be a way to get stuff done fast. However, the issue of scaling it still remains a big conundrum. Kraft Foods, now Heinz Kraft, had a problem where the way they did their financial justification for rollouts of new systems meant that when you got to the break-even point for a manufacturing plant for a new system, and now you had diminishing returns, you stopped deploying. Well, they had 80 plants in the United States when I worked with them in the mid-1990s, and the last 20 never got a new system, because at 60, they hit that diminishing returns point, so the CFO said, you're done. Let's go do the next thing. And you go out to those last 20 plants, and it was like traveling through time. You had this architectural museum, right? Kind of like going to the Field Museum of Natural History in Chicago, and there's that dinosaur, and there's that dinosaur, and these are systems they're still using to make cheese or make Oscar Mayer hot dogs, because they never got reached due to the financial metrics that were used to drive those decisions. That unintended consequence permeates many, many companies. And the result is this legacy tar baby never goes away, and in fact can be quite significant, and that inhibits your ability to scale and deploy new stuff. So speed becomes a big problem. You never see the result. And the business people start questioning whether the technology guys know what they're talking about, because they don't see the result. Final point, which is one I think that's somewhat distinctive at this point in time compared to, say, 20, 30 years ago, is there is a generational shift as the boomers, at least here in this country, move into retirement en masse. And that means if you had programmers like First Data Corporation does, the largest credit card processor in the world, who are branch and link register assembler programmers, and you can't find those skills at the Indian Institute of Technologies. Nobody teaches assembler anymore. Nobody knows how to use a yellow card anymore. That stuff's so old school. There's a group of programmers that First Data employs in Melville, Long Island, that they pay an average of $180,000 a year to be programmers, because there is no other option. And the average age of that programming team is 58 years old. Guess what? Where's that knowledge going to go when those guys finally decide, I'm going to take my boat and I'm going to go sail around the world, I'm done, or I'm going to finally get my handicap under 15? The answer is not, or under 20. The answer is not intuitively obvious. It's not somebody you're going to source from India or from Bratislava or from Dalian, because this stuff has long since been lost. So the loss of knowledge that is coming from loss of experience is a very big strategic issue for many customers in the technology management space today. And again, no easy answers have been forthcoming here that make people go, oh yeah, I can roll over and go back to sleep now. I don't have to worry about that. You got to worry about it. Well, one of the ways we think people can address some of these solutions, and I'm not saying it solves them, but is through taking an approach using intelligent automation. We think AI has a part to play in tackling those problems. First of all, on the outage prevention and cost side, what we built on top of our platform was a solution that is aimed at data center, end-user computing, network operations, and security operations center automation. And the point, I guess, a couple points I make. One is we actually like it when customers have already tried to automate with something else, because now they understand how hard it is. If you haven't tried it, there is a belief in the marketing brochures that you plug this stuff in, you turn it on, you write the scripts and you say go, and magic happens, you're at 85 to 90% automation and you can take half your people out. And in real life, you can do the major normal processes through a script because they're stable and they don't change much. But as we all know, if you've ever actually run a shop, in the real world, you have 500 exceptions that are not normal, that are highly dependent on the individuals working on it, that generally aren't documented, so you can't write a script for them. So that means they don't get automated. And that means the effective automation rate for people who have attempted automation at scale is usually in the 20s. And I was talking to somebody at a very large bank a couple weeks ago. They said they've gotten to 30% on a couple of their use cases. But generally, they're in the 20s. And that's where we come in, because we help them take it from 20 to 80. And it's something we commit commercially to doing. In fact, we do all of our commercials on Gamechanger with our customers, based on real economic benefits rather than some other form. And I think the point I'm making here is it's driven by the AI engine's ability to dynamically handle all the exceptions, because that's the hard stuff. Now, one thing that many of my colleagues in the service provider space, the consultants, would say is, yeah, but don't you want to see if you can process simplify first? And I'd say, yeah, that gives me fewer things to have to handle, and it may eliminate some cost and get some early wins for the customer even before you put the automation tools in place. I know at DXC, for example, who we work with, they're using a process in their own data centers right now where they take 6 people for 6 weeks doing process simplification, and they're averaging around 30% cost takeout just by doing that. Now, they haven't done the automation yet. They're expecting much more dramatic results when they do. But I think it illustrates that there's nothing wrong with process simplification or if attempting automation to begin with. It's just you have to understand there's limits to scripting tools as a technological way to do it. And that's where our AI engine comes in. We use association chaining as our technology approach in our AI platform. We don't draw the graph ahead of time. Our tool does it at runtime as it encounters the issue. And it uses these things called knowledge items that sit down in that knowledge repository, the graph database, and chains them together in an appropriate way. It figures it out each time, which as a result means you can use a relatively modest set of knowledge items individually, and when you do all the permutations and combinations that, say, 300 could do, you very easily cover a very broad set of exception conditions. And that's how we get to the 80 to 85%. We have a large bank in Europe right now running a production with 362 knowledge items is the total number they use to run their data centers. And they've taken 70% of their people out. So you can do it. It is real. This is a game changer versus a science project kind of a solution. And while it may sound like I'm trying to sell you one, I don't know if you have a data center, so you may not want to buy one. I think the broader point for people thinking about AI and its usefulness at this time in early stage and kind of the maturity of the technology is there are solutions, a select number, who can do this kind of thing. There's a lot of science projects. I think we had a statistic, last 18 months, 2,200 AI startups have been announced, venture-backed in one way or another. So all of them have at least an idea, if not a technology and maybe a patent. None of them have a product that's commercial. They're all looking for a lighthouse customer to help them build one. And that's okay. That's the way our innovation works in our economy. Thank God for that. Point is, though, that is a different kind of customer purchase situation and risk profile and upside than someone who's got something that is commercial, can scale and addresses an economic benefit and economic issue, which is what we think we're doing in this IT space. Now, the other thing about speed I think is important. Our view is that AI has the potential, although this is still somewhat driven by methodology and by the limitations of the technology itself, to be able to be deployed at scale much faster than some other technologies that many of us are familiar with. So in our case, we actually commit to this timeline to clients. You scale it 80 days from start and 60 days from signing the license. And the way we do that is we bring an existing repository of KIs to start with, and we start running in production actually within a couple of weeks after we stand up the instance. And then building out incremental KIs as they have unique exceptions to their environment becomes the thing we continue to do over time as we deploy the solution. But this notion of getting something up and running fast and scaling fast, I think is one that still is more talked about than done. And yet it's one I would encourage anybody here, whichever side of the table you're on, to think in terms of speed to outcome as one of the key things that ought to be part of any approach. There's a review recently that was published in a healthcare journal about experiences in putting Watson into the healthcare informatics space. And one of the things that the reviewer commented on was how long it takes to draw a graph so that Watson can actually process an event. And they were using the example, I think, colon cancer, reading an MRI, and then from that being able to do the diagnostic to suggest this might be colon cancer as a result. Well, 2 oncologists, 2 radiologists working for 6 months to draw out the graph before you could run 1 case against Watson. We look at our approach, which is association chaining, and we're not trying to solve that problem, obviously. I don't pretend to know if that would work here or not for us. But the speed factor becomes significant if it's 60 days versus 6 months for 1 use case. So that's something we're trying to suggest people need to look at as well. Speed to the answer, in addition to the elegance of the technology. Last point I guess I'd make about Hero is that in a lot of ways, our founder and visionary and our resident rocket scientist, Chris Booth, who owns the patents for these things, really decided to spend his time looking at this in a way that would mimic the cognitive processes that people's brains use. So that's another reason why this association chaining notion is really interesting, because it's a lot like the way we deal with problems when they're presented to us. If you're given an issue, it's not like you have a script. I mean, you may, but again, for things you encounter all the time. But for a new issue, we assemble disparate pieces of information, context, knowledge that we have in various places from prior experience or from information we have to assemble on the fly our answer on how we're going to deal with this issue this time. And that's really what the notion is behind the technology that runs inside Hero. So there's an understanding dimension in our knowledge core. There's the learning dimension where we add new knowledge items that make the platform smarter over time and can handle more things. And then the machine reasoning dimension that allows us to handle it dynamically, chain through and associate knowledge items for each issue in a way that actually recognizes patterns over time and gets smarter about how to do that more efficiently. That's kind of a quick overview of our thinking around game changing as opposed to some of the issues that are confronting us, I think, in considering the science project aspect. And I offer that more maybe for food for thought for the panel conversation to follow. I guess I'd say it's important to recognize that at Arago, we chose a very clearly defined business domain to shape and build our solution into. And I would say that's one of the things you have to do with an AI engine still. You can't, the fuzzy logic concept, fuzzy is not a good thing in AI. Clarity is a good thing in AI. And to that end, having knowledge items that are clear, conditions and actions, to have a semantic graph database that is clear, to have a view of the heterogeneous environment that you may be working with that's clear. The clarity of definition is a very important success factor for any AI engine to be successful, whether it is a science project or whether it's actually something you're doing at scale.